the computer, and let me bring up the the PowerPoint presentation. So you should all, oops, something's happened to my, oh, here we are. Okay, so this is I think, the second or third presentation that is part of the electronics course. And again, I'll put all of this up on the website so you can look at it again. So what we're going to do is we're going to go through the slides, and then we're going to have a little demonstration of multimeter and how to use it. So there's basically, three learning approaches: watch it and ask questions, do it online, and that's where Tinkercad comes in. And then you could also do it by building various kits, and we'll get into kit building. So electronics is 50% lecture and 50% experimenting, but you want to do it safely. So we're going to talk about safety in the next few lectures, just to make sure you don't get yourself a shock and get yourself electrocuted, or do something else to yourself. So today we're going to talk about the multimeter, going to talk about safety first, uses, the names of it, types of multimeters, what you want to watch, what you want to measure, typical layouts, and then some examples with the various multimeters that I've got here. So one of the things is that there's basically three or four uses of a multimeter. And one is to do AC electrical power work. So, 120 volts, 240, and 480 volts. And, here the danger is you could electrocute yourself if you use the wrong meter, and you end up killing yourself. If you're doing a lot of this work on electrical work, you should get the best meter, one that's designed for electricians, and that the manufacturer is a reputable manufacturer. Some of the other things, if you're doing high voltage work, like greater than 150 volts, again, there's a danger here of electrocuting yourself. And, you can get various probes that are used to measure high voltage. This is used basically if you're getting into tube amplifiers and tube radios. They may have 300 volts, 500 volts, or 600 volts. The other thing is that some of the meters, as you'll see, are not, well, if you're doing high current work greater than 200 milliamps, you can get into trouble. And the danger here is that the meter can overheat and catch fire, and then you can also get hurt if you start a fire. The other thing is, there are special meters here, like an AC clamp meter, or you can use a DC shunt, or an AC current transformer, or a DC clamp, or an AC-DC clamp probe if you need to measure the higher currents. And we'll see some examples of these as we go through. So your general meter that you can buy almost anywhere these days is meant for, less than 150 volts and less than 200 milliamps. And some of the meters I wouldn't even use for 150 volts, and you'll see some of the examples coming up. So yes, your multimeter can kill you. So, so some of these ones up here, like on the right-hand side, Harbor Freight used to give these away free or sell them for like $9.99. So, while these ones here are fluke meters, sort of the top of the end line. So the things what you need to look at is the safety user rating, and we'll go into all of these things shortly. The maximum voltage rating, the price and the manufacturer. Are you buying it from, getting it from Harbor Freight with sort of a no-name product, or something off the AliExpress website, or something made by a reputable manufacturer. And then the other thing you want to check is your maximum current rating for it, especially if you want to measure, something in the 2 to 10 amp range. And we'll see some examples of that. And also, what sort of input protection circuits does it have? So, and the thing is also that for measurements, you can do differential measurements because the meter basically is not grounded. So you don't have to do measurements to ground like you do with an oscilloscope or with a spectrum analyzer. And we'll cover grounding next week. And so one of the probes doesn't need to be connected to ground when you use one of these isolated meters. But the thing you have to be careful is if you're trying to measure something and you put one probe on minus 100 volts and another probe on plus 250 volts, you're going to get 350 volts across the meter, and maybe your meter isn't designed for 350 volts. So when you're doing some measurements not using a ground, just be careful of what you're measuring because the voltage may be a lot higher than the rating of your meter. Now, there's some new features with the meters. That one is called NCD or NCI, which means non-contact detection or non-contact indication. And this is designed to let you know if there's power in a wire without making actual electrical contact. Now, most people don't really know how to use this feature, and sometimes it depends how you hold the meter, whether it works or not. So, I mean, before using it, you should test it on a known wire just to make sure that it actually is working. And because people end up shocking themselves because they think that there's no power there because it doesn't indicate anything. But check. Check if you're doing working on AC power like an electrical outlet. Check with a lamp or with a multimeter that is working, just to make sure that there's no voltage there. And then lock out the power supply. Lock out the breaker or your shack power supply if you're working on it, just to make sure that no one turns it back on again. And then, most of the meters now come with auto ranging. We'll see some examples of that. So, some of the meters that have a range switch on it, like if you set your range switch to 100 millivolts full scale and you put 100 volts into your meter, you may actually end up blowing up your meter if it doesn't have adequate protection circuits. And then automatic ranging will automatically select the correct range that you want. But there are some pros and cons with that. And you can also disable it if you want to. Now, one of the most important ratings is the CAT ratings. And people all often get this confused with the voltage rating. Although the CAT rating and the voltage rating are somewhat related, it's not really the same thing. The CAT rating is basically how much protection is there between the source and you when you're using the meter. So if you were, let's say, doing measurements on the power grid or the power line coming into your house, for example, before it goes to your circuit breaker box, you would need, or you should have, and strongly recommend it, to get a Cat 4 meter. Now, if you do measurements on the other side of the circuit breaker box, where you actually have a circuit breaker, you can use a Cat 3 meter. And then if you're using it let's say, for example, you plug in your radio into a circuit breaker and your radio has a fuse, or your power supply to the radio has a fuse, you can now use a Cat 2 meter at this level. And if you have, let's say, a low voltage power supply that, let's say, it puts out 13.8 volts for your radio and also has a fuse on it, you can use a Cat 1 meter. Now, I didn't know that there were Cat 1s and Cat 2 meters out there until I went through my meters and found out I actually had some Cat 1 and Cat 2 meters. And I'll show you those And then Cat 3 seems to be the most popular one. Cat 4 meters, as you'll see, are very expensive. But if you're working on this level all the time, you need a Cat 4 meter. And here's just another example of, if you're working on the power line coming in, you need a Cat 4. If you're working on, what's coming out of the distribution panel, Cat 3. And then if it goes into something, Cat 2. And then if it's a low voltage, it can be a Cat 1 meter. Now, safety is key. Now, I was just looked up the price with a Cat 4 meter rated up to 600 volts, and the Cat 3 meter. This is the same meter rated up to 1,000 volts. Will cost you anywhere from $1,800 to $3,600. But the question is, what's your life worth? And I guess if you're dead, it doesn't really matter. So, if you're working on the power distribution, you need to get the best meter just to protect yourself. So, what are some of the things to do? If you're working on your shack or on your test bench, make sure you have a good electrical ground. Have a ground fault interrupt breaker or outlet for your Radio Shack or test bench. Have this installed by a qualified electrician and make sure it's working. Make sure you know what you're doing. If you're doing some troubleshooting and you have no idea what you're doing, is get someone with some knowledge to help you out. One of the things is, make sure that your meter is working. So this is actually, here's a fluke meter. And this is what's known as a proving unit. So if you're going into, this is meant to go into an explosive environment, or if you're going to do some work on AC distribution system and you want to make sure that your meter is working before you go in, you test your meter every time you do a measurement, just to make sure that the battery is okay, the test leads are okay, and everything works. Have a buddy with you in case something goes wrong. And, if you really don't know what you're doing, stick to 13.6 volts, anything below 20 volts, and work on that only. So, so next thing you need to look at after the CAT rating is to look at what your voltage rating is of your meter. And I'll show you some examples. It could be a 1,000 volt rating, could be a 600 volt rating, or a 300 volt rating. Most meters will either be 300 volts or 600 volts. If you need to measure higher voltages, you need to get a high voltage probe that goes with your meter. The other thing is, look at the manufacturer and look at the price. The gold standard is the fluke meter. These days, you can get a very good fluke meter for about $200 or $300, which is a Cat 3 meter, and I'll show you a couple examples of that. You can also get meters from other manufacturers like Amprobe, Unity, Circuit Test, Owen, which are reputable test instrument manufacturers. You can, get some brand names from Canadian Tire or Home Depot. I'll show you two of those that, you have to be careful with. And then, you can get the dollar store variety, which they either give away free or you can get for like $1.99 at Harbor Freight. So be careful. I mean, if you're only measuring 13 volts and low amount of current, these are adequate. But, once you start getting into higher voltages, especially anything to do with 120 volts AC, you don't want to use a 999 meter. And what you get for is, some of the meters that I'll show you will not be safety tested, or they overstate their safety rating, especially if you buy them from AliExpress or from like Banggood, if they're not coming from one of these manufacturers, if it's a no-name manufacturer. Maximum current rating. Most meters are designed to only operate on 100 milliamps or 200 milliamps of continuous operation for the current. Although they may be able to measure 10 amps, what they'll have here is a rating. They'll say, okay, on the 10 amp range, 10 seconds every 15 minutes. So that means you can measure up to 10 amps for 10 seconds every 15 minutes. So then the resistor or the shunt inside the meter has to cool down until you can operate it again. And the resistor will get hot and overheat, and then your meter will catch on fire. And the recommendation is if you really want to measure things more than 100 or 200 milliamps, get yourself a clamp meter, and I'll show you some examples of that. Or get yourself a shunt current transformer and a separate meter like that only measures AC current or DC current, and not a general purpose meter. Like if you want to measure 23 amps that your radio might want to use, then get yourself a meter that's designed just to measure 12 volts, 23 amps, and that's it, rather than a multimeter. Input protection circuit. See what your meter has. It can have no protection. It could have some replaceable parts, like a fuse or a semester or a gas discharge tube, and these generally cannot be replaced. Like a semester and the gas discharge tube are designed to protect yourself, and it's built into the meter. Some meters have an internal fuse that you can't replace, so if the fuse goes, you have to probably throw the meter away. Now, most meters will have some fuses, one fuse for the general input, which will probably be like a 200 or 300 milliamp fuse, and then like a 10 amp fuse for your 10 amp input. But this may not always be the case. Most meters will have banana plugs, and you'll be isolated from ground. Um, but some meters will have like a BNC connector, or meters that you plug into an AC outlet may actually be grounded. So if you plug if you connect your ground lead to the hot side of the power line, you'll create a short, and you can cause a fire, or you can get a shock, or you could electrocute yourself. So again, if you have a meter that's connected, one side is connected to ground, be careful. This is especially true with older style meters. Oh, the one of the things you have to look at when you're looking at the voltage limit, it's what kind of connections are there on the meter, and then but more important is inside on the PCB board, which you can't see, is how far are the traces away from each other, and then on the switch, how much is actually your switch is rated for, and they may have some circuit traces that are very close together, and also some of these circuit traces may act as a fuse and actually melt if you put a lot of current through them. The other thing you want to look at is the input impedance of your multimeter. Typically, it's going to be around 10 mega ohms. So it's not going to load the circuit that you're measuring. If you're looking at some of the old analog meters, the impedance of your meter could be as low as 1 kilo ohm. And if you hook it up to some circuit, it may actually load down the circuit and reduce what you're measuring. So there are things as voltmeter, ammeters that only measure one parameter. We used to have a thing called the VOM, volt ohm meter. And then the next thing was the vacuum tube voltmeter. But you have to be careful. Usually the input is grounded. Then we ended up with digital meters, and then multimeters, and then multimeters um, that are like a test instrument, like an oscilloscope, which we'll look at in 2 weeks on how to operate your oscilloscope. Types of meters, you can use them for electrical power, AC measurements. Is it a test instrument or something from Harbor Freight? Is it an analog or digital meter? Analog meters are still good if you're trying to look for a peak or a valley and adjusting something. Some digital meters may have a bar graph that may help you adjust it. What size do you want? Is it a pocket one? Is it a handheld one? Input, is it direct connection or is it a clamp on? So these are some of the parameters you want to look at. Battery requirements. Many meters use 9 volts or a transistor battery. Newer meters use either 1.5 volts. Usually it's a double A cell, 2 or 3 double A cells, or maybe even a triple A cell. Some may use non-standard type batteries, and some may be rechargeable. And the thing is, you want to have it be fairly easy to get access to the batteries and to the fuse. You don't want to take your whole meter apart to replace the fuse or to replace the battery. Some meters are easier to take apart or not. Some you have to take the whole backpack cover off to replace the battery, while others meters you just unscrew it and out comes the battery compartment and you replace the battery. So here is a typical meter. We'll look at it in more detail. You'll have an LCD display. You'll have some sort of range switch. Here you can adjust it for different ranges. Here it's automatically adjusting. You just set it to volts and it'll pick the range automatically. You have a continuity test, which will tell you if if it's connected together, and then you have 3 sort of probes, and we'll look at that when we go live. When you're looking at AC voltage, this seems to be quite standard, although some meters may not have AC. Some meters may not have the resolution. As for DC, like you might be able to measure like 100 millivolts in DC, but for AC, it might only measure, start at 10 volts or 100 volts. One of the things you want to look at, is it true RMS or not? If you're measuring other than a sine wave, like a square wave or a triangle wave, are you going to get a true reading or not? And you're going to pay for all of these features. And then the other thing you're going to look at is the frequency range. How high does it go in frequency? If you're just measuring AC voltage coming out of the AC outlet, and you're looking at maybe going through a transformer into a power supply, maybe 20 volts, 10 volts, 50 volts, then all you're looking at is like 60 hertz. So frequency range is not that important for you. Again, it may not cover the same range as DC. If you want to have AC current, best is to get a clamp-on meter. I'll show you some. Some may have it as a direct measurement, some may not. DC voltage seems to be standard. DC current seems to be standard too. Some of the newer meters will also measure DC on the clamp-on. Resistance may be available or not. Some meters may not have that. And then you have a continuity buzzer or a diode test, which is useful just to see if if a couple of wires are hooked together or not. And then you get all the other possibilities. Some meters will measure temperature, some meters will measure frequency and duty cycle and period. Some will do a capacitance test. Some will do a battery test. Some will measure a transistor gain. Some will have this non-contact voltage detector, and then other meters can also measure inductance. So again, you get what you pay for. Not every meter will have everything. And you'll have to look carefully. So if you're just going to measure frequency once in a while at a low frequency range, like less than 100 kilohertz or something, it might be useful to get the frequency in your meter. But if you're going up to megahertz and hundreds of megahertz, it may be useful for you to buy a frequency meter that just measures frequency. And if you're doing a lot of measurements of capacitance and inductance, it might be useful for you to get an LCR meter. So again, look at what you want to measure, how often are you going to measure it, and should I get a separate meter or something that has everything built in? The other thing you need to look at is, what range, what accuracy, and how many digits you want. So, 2000 is a popular count. So that means the meter goes up to 2000. So that means you can measure, 1.999 volts in 3 digits. If you go to 2 volts, it automatically drops back down to only 2 digits. There are other meters with a 4,000 count, a 6,000 count, an 80,000 count, and a 20,000 count. You can have like 2.5 digits, 3.5 digits, 4.5, 5.5 digits. 3.5 seems to be the most common one. And then accuracy, how accurate do you want it? And if you want the accuracy, you're going to have a standard, or you're going to have to send your meter to the lab and get it recertified every year. And that's quite expensive. So that's not recommended unless you're in the electronics business and you need your meters to be calibrated every year. The other thing is, look at your inputs. You may have a positive and negative input. You may have three inputs, a common, a red, which is used for volts, ohms, and milliamps, and then a special one for the 10 amp circuit. This is most common for most meters. The Fluke seems to be a little bit different. It has a black one. It has one a red for measuring volts and ohms, and then a second red one for measuring microamps, milliamps, and 10 amps. And then you get some laboratory instruments that have actually 4 leads, and you can null out the resistance of your test leads and get more accurate measurements. Features, auto function, you press a button and it automatically selects everything. You get auto ranging or a manual range switch. You get things like data hold, that'll hold the data for you. Because I'll show you, it's not easy sometimes to use your meter and to check your circuit. You might have a minimum maximum mode. You might have a peak mode and also a relative mode if you want to null something out and measure something relative to something else. Advanced features, you get data storage, how much you want to store, how long. You get, meters that you can hook up to an app or software. You get RS-232 or 428 or USB output, Bluetooth, Wi-Fi, and remote reads out. So these are all the features that you can get. You can get analog meters, and I'll be showing you some of those. They're still pretty good. So, in conclusions, you can get meters from a pocket meter to any of these ones with various features. You can get a lab one like the one here on the right-hand side, with a whole bunch of meters and options. And, this is, I think, like 8 or 9 digits, which most cases you'll never need. You can get some bench meters like this. You can get a clamp on, which I'll also show you in a second. And then you can get some that will actually display some graphs and will actually take histograms of voltages and stuff like that for you. And these will run you maybe $400 or $500. This one might cost you a couple thousand of dollars. These ones typically, go from about $30 to a couple $100. And then you get into like $800-900. And then for your Cat 4, you're getting around the $2,000 mark. So the next thing is next week we're going to talk about grounding, and then we'll get into the oscilloscope. So, any questions on that before we get to actually looking at some of the meters?
Roy, is there any way that we can use a multimeter to test the condition of a battery? I know we
Uh,
can measure the voltage, but how bad it is or how good it is, and can we
yeah,
measure that?
some meters actually will have a battery scale on it. I'll show you a couple of meters that have the battery scale on it. So let me just share the my video here. I mean my camera. So you should be seeing a whole bunch of meters now.
Whoa.
So we'll go through a number of different meters. So this meter here, maybe I can. Okay, it seems to be all right. So this meter here, let me just move it over here. It might be a little bit better. So this meter here um, is one that I got at Canadian Tire, and probably the reason I got it is because it has the battery scale here to measure the meters, to measure batteries. But when I look at the rating here, which you can't really see, it says, you know, it says here Cat 1, which is the least amount of protection, and it says 500 volts. So do I really want to use this meter at 500 volts if it's Cat 1 rating? Probably not. The other thing you need to look here is it says it's fused, 315 milliamp fuse. So I said, okay, that'll protect me. But over here it has a 10 amp range. But then right here it says unfused. So if I leave that and then up here it says maximum 10 seconds each 15 minutes. But if I leave it connected, I'm not going to blow a fuse. So um, I have to really be careful about using this meter. So I would probably only use this meter for batteries and low voltage. And you have a black lead here and you have a common lead here, and then for 10 amps is that. So this is one from Radio Shack, not from Radio Shack, from Canadian Tire. So I would use this one only for low voltages and DC and batteries. And again, one of the things over here is that the DC voltage range goes from 200 millivolts up to 500 volts. But if you look over here on the AC range, it only goes to the lowest range is 200 volts, and the next one is 500 volts. So if you're measuring like 1 or 2 volts, you're not going to get the resolution here because you're only going to get one digit display. Like here, you get no digit display, and then over here, no digit, 2 digits, 3 digits. So you're not going to get the resolution here for the AC. So we'll forget about this meter right now. So next meter is another meter from Canadian Tire. Um, so I bought this meter because it has range, it has relative measurements, it has data hold. Data hold is good because when you have these probes, ideally you should have these probes like connected to something, but we'll probe some circuits. But sometimes you can't, you're watching here as where you're probing and you can't look at the meter at the same time. And then if you look at the meter and you move your probe a little bit, you might short something out. So the data hold feature is good. It measures capacitance. It measures the gain of a transistor, and it also measures frequency. So, that's probably the reason I bought the meter. But if you look down here, it says it's a category 2 meter, 1000 volts DC, 750 volts AC. So again, Cat 2 is not the best protection for you. Then also when you look down here, it's got a fuse for 400 milliamp fuse, and it's also got a 10 amp fuse now. So at least, it's got a fuse and a 10 amp. So this is one step up from what from the first meter. I mean, it's a category 2 meter. Now I bought this meter here from at RP Electronics from Circuit Test. They make different instruments and things like that. One of the reasons, and it was like about $30. One of the reasons I bought it is because it has all the ratings on it. So it says fused 200 milliamps maximum 300 volt. 10 amp is fused 10 seconds every 15 minutes, and it's rated as a Cat 3 for 300 volts. So this is one of the meters that I'll be using for some of the demonstrations. So it measures voltage, AC voltage, DC voltage. It doesn't measure AC current. Um, it measures ohms, and then it also has a scale here for a 1.5 volt battery and a 9 volt battery. So for your typical batteries, your dry cells, not your lithium ion batteries, but your batteries, you can use this to measure the voltage of it. So that's very good. Now, this is the fluke meter. Um, it doesn't have the category listed on it, but if you go to the website, so it's got a 320 milliamp fuse. It doesn't. It's got a 10 amp fuse, but it doesn't say anything about rating. So I checked it on the manufacturer's specification, and it's 10 amp continuous. So I can leave this hooked up to anything up to 10 amps, and it won't burn out. It's a little bit different in you have different settings here for current. So milliamp and microamp are measured here. Amps are measured here. It'll cover AC, DC, millivolts, milliamps, microamps. And then it also has like a continuity checker on it. So when you hold the probes together, it makes a noise. So if you're probing, if you're just checking wires or something to see if you have continuity, or you want to check a diode, um, you can use this type of meter. It has range, relative, minimum, maximum, and the hold feature. So it's fairly good, but this is probably about $300-400. And look at the size of it; it's quite big compared to the other one.
How much you pay for that, Roy?
Well, I've had this for a long time. I think you can get like $200 or $300 now for a good fluke. Like if you go to RP Electronics in Burnaby, sometimes they have a sale on. Or if you can get a fluke meter at a swap meet, you can't go wrong. They're made in Everett, Washington. It's sort of the top of the line instruments. So this is a good one. Also, if you look at this meter here, this is an old fluke. It only goes up to 2 amps, and you have to push in these buttons here on the side to measure. But it's a fluke meter too.
I have a fluke older than yours.
Okay. But I would say if you're measuring low voltages and you're dealing with transmitters, you know, um, sort of any meter will be okay if it says category 3 on it. Even if you're doing a lot of measurement on electrical power, I would get something from a reputable manufacturer that says Cat 3 on it, just to be on the safe side. Now, if you if you're going to analog meter, this is an analog meter. Again, this one has battery scale on it. You can see the red and the green used to measure batteries like 1.5 and 9 volt batteries used to measure current. The thing here with this one is ohms. The ohm scale is not linear, so what you need to do is hook this together, and then you have a wheel on the side, and you have to adjust it so that the meter reads zero, and then you can measure your ohms. Um, so, this is good if you want to just see, for a deflection or something, or adjust minimum and maximum. Some of the scales are, you'll have multiple scales and you'll have to look at it. Some of the scales may not be linear. So this is an old, this one is available at Canadian Tire. Don't know if it has a rating on it. Yeah, it's a Cat 3, 300 volt rating, 600 milliamp maximum fused. So this one has a Cat rating on it. I think the meters with at Canadian Tire are getting better um, than what they had a few years ago. And here's an old analog meter from Radio Shack. It says it's got 1,000 volt input, but the probes are a little bit finicky compared to the fluke probes. Um, so I wouldn't necessarily hook this up to 1,000 volts. If I was to hook it up to 1,000 volts, I would make sure that these things are clipped onto the what I'm measuring, and I would stay away and then turn something on and take a reading and then turn it off again. I wouldn't hold this meter in my hand and do some measurements on high voltage. Um, Again, it doesn't measure AC current but DC volts. But it's a good meter to measure, for deflection and things like that. So next we have, if you want to measure current, here is an old current meter. What you do is you open this up and you put your wire through it. Or if you're measuring like AC power, you have something like this, where you plug this in here into the outlet, plug your thing in here, and then you've got ×1 and a ×10, so you can actually measure low currents. You just put your meter in like that. Oops, put your meter in like that, and then just read the meter. So this is an old meter from General Electric, where you adjust the range down here. It goes up to like 600 volts, and I think it goes up to 750 amps of power. So that's an old one, old analog one. Now this is a digital one that I got at Radio Shack. I mean, not Radio Shack, sorry, Canadian Tire. So that one is basic, it does continuity, ohms, volts up to 600 volts, goes up to 400 amps because you put the wire through here. It's just AC, and it's rated a Cat 3. So I mean, if you're doing a lot of AC power measurements, I would get something like this. The leads go in here for voltage, current goes through here, but it only does AC current. Now you have another meter that I just got from Unitet, which was about $40, which is supposed to measure DC current. Also, I haven't measured the DC current yet. We'll probably try that on some of the ones. And this one is rated as Cat 3 for 300 volts and Cat 2 for 600 volts. And it comes from Unit, UN-T. And this you can get at like Lee Electronics and sometimes also at RP Electronics. RP Electronics tends to have more fluke meters. And again, it's digital, digital readout. and auto ranging and things like that. Now, okay, there's one more meter that I want to show you, and then we'll do some measurements, so some quick measurements. So I got this meter about a year ago, and the thing I like about this meter is that it's a digital voltmeter. It's rated. Let's see. It's rated Cat 2, 1,000 volts. Goes up to 10 amps. Has a fuse in it. So it's a meter here. But the interest, and it's got some functions here, like this happens to be temperature, but it's got relative and up and down peaks. But the interesting thing is, if I take this lead here and plug it in on this one over here, which is rated at 700 volts, and I flip this over to here, I get an oscilloscope. That's rated up to 700 volts. It's isolated from everything, so I don't have to worry about grounding. And it also tells me here what the voltage is, the peak voltage, the average voltage, and the RMS voltage. It also gives me a frequency. It says it goes up to 40 megahertz. Now the thing with this is you wouldn't use these probes here. You wouldn't use a wire probe like this to measure 40 megahertz accurately. But I did try it on my Bofang the other day at the VHF, and it did give me a wave, a sine wave that looked right. The frequency, I used about 150, 145 megahertz for the signal. The frequency said only 50 megahertz, so it was off on the frequency, but I could at least see what the waveform looked like. So we're gonna, and then you have a option of AC or DC input for the oscilloscope. So we may use this to measure some things, and because we're isolated from ground, it's also good.
And how much you pay for this, Roy?
I think it was only about $100 from Banggood, and the make is Must Cool.
I like the oscilloscope type. I mean the part. I always want to buy one.
Yeah. They make a lot of instruments, different values. I'm not sure if I would trust it, on power distribution circuits, but for anything 100, 200 volts. Even what you need to do is when you're doing these measurements, don't if you need your Cat 4 meter or your really good Cat 3 meter. If you're holding it in your hand and you're doing some measurements here, if you're holding this in your hand like this and then doing measurements with the probes, you need that good measurement, a good Cat rating, and you want that isolation. But the thing is, you put your meter down and then you do your measurements. So if something happens to your meter, you're away from it. The other thing is, we'll now just look at a simple circuit and do some quick measurements, and then that'll be it. So here, let's turn on the fluke and let's do a voltage measurement. This is a simple circuit here. Oh, the other thing here is that if you're probing here and then trying to look at so what we have here is basically basically here we have two batteries, and we have a light bulb. So when you press this switch, the light comes on. So just a simple circuit. And then we have to try to get all of this in range here. So, okay, so that's not too bad. So, if so, one of the other things is you can get a meter like this. Now, this one has no rating on it that I got on AliExpress. So I wouldn't use this for anything higher than like battery circuits, 50 volts or something like that. But it does have, the thing here, you can hook this on here and, and then measure your voltage and actually see it. Rather than looking at your meter and then trying to do the measurement. So for voltage, basically what you need to do is put it across your terminal. So these are two batteries in series, and we'll cover series and parallel circuits in a future video. You measure this, it's 3.2 volts. You can measure individual batteries, 1.59 volts, 1.59 volts. One of the things is that I'm just going to make it a little bit simpler. I'm going to hook this to, oh yeah, and for most meters, I mean, you can test to see how accurate your meter is. Like if you put it this way, it'll indicate minus 3.1 volts. That's because the probes are reversed. But if you do it this way, it'll give you plus 3.2 volts. So you can test to see how accurate your meter is by just reversing the leads. So what I'm going to do is just use one of these clips here and just make it easier. So I'll just connect it here, and you can measure the voltage of one battery, the voltage of two batteries. Two batteries is here. Oh, just a second here. What's going on? Okay, I'll have to take a look. This should be two batteries. So you'll notice that because the battery has some internal resistance in it. Yeah, I'm having some of the problems looking at the meter and trying to keep these connections going at the same time. But if you press the button, it'll drop a few volts. This is now 2.9 volts. So we'll actually do some calculations and see what, oh, here, just a second. This makes it a lot easier. So here, I now have it connected with it, hooked up to the meter, and then you just press this, the voltage drops down, and we'll actually calculate the resistance of the battery in a future session. Now, if you want to measure milliamps, what you need to do is switch this to milliamps, move this over either into the amp position or the milliamp position. Since I don't know what it is, we'll start off with the amp position. And to do that measurement, I just measured the power coming out of the battery, which you shouldn't be doing, but because it's a dead short and the cables are getting hot, so don't do this. So what you need to do is take off. Oh, I think I might have burned out a fuse in the battery. So if I do this, oh, okay, it still works. So what you need to do is break the circuit, put your meter in, and then I'm measuring here 1.9 amps, and then I could switch down to the milliamp range if I want a more accurate reading.
150.
159 milliamps. And so that's how you measure milliamps. Now, since I've got this connection off, we can actually measure the resistance of the light bulb. And we'll actually do a little experiment as to why the resistance of the light bulb is different using Ohm's law and using the meter. So what we do here now is switch the meter over to ohms. So what? Okay, just this. Oh, so see, when you have it set up in the wrong one here in milliamps, it won't give you a reading. So what you need to do is make sure you put this over on the right one, and then it'll give you some sort of indication like low, and it also shows you a bar graph. So you could check, you can put these two things together. And it's telling me that this is 0.8 ohms. Now, if I want to, for example, null out the resistance of 0.8 ohms, I'll just press the relative button up here, and it zeroes it out. And now I'll connect it to my light bulb.
Oh, Roy.
Yes.
Can I suggest you put a piece of white paper beneath that breadboard? I kind of can't see clearly where your clips are going to which test point. Okay. If you slip a piece of white paper underneath, I may see it clearer.
We might. I thought black was better, but maybe we just we'll see what happens. Is that better?
Ah, yes. Okay. 100 times better.
Okay, so I mean we're still learning how to do these videos. So anytime you see something different that you like, to be different, let me know. I'm open to experimenting. Okay. So what we do now is we connect the ohm meter across the light bulb, and it's telling me that it's 2.1 ohms. 1.9 ohms, so around 2 ohms or so. And we'll do some calculations with Ohm's law and find out why that's different. And then the bonus question is, why is it different? But the other thing you can also do is with the continuity checker. Like for things that are low ohms, like you can, connect these things together, and you don't have to look at the meter. And if I want to see if the light bulb works, I just hook it up and it shows me that the light bulb is good. I can use that like for fuses and for things that typically are less than 100 ohms. And we can actually do an experiment to find out when the continuity stops working. So that's the demonstration for the multimeter. So let me stop share. Okay. And let me turn off the recording. If I can find the button. Oh, okay, so I'm gonna stop the recording.